Hello everyone and good evening to one and all. I, Sona PS with my co-host Vaishnav VR are very much honored to welcome all the dignitaries, guests and delegates with great joy for today's session. This is our webinar session organized by the IEEE SB SNIT, IEEE IAS and IEEE IES SBC SNIT. Hope you all enjoy.
Today's webinar is about Python in today's industries. Now, major programming languages such as Python, Java, C++, etc. support it. Due to the rapid expansion of the ecosystem, this makes it one of the more unique technologies to continue to be relevant for the foreseeable future. So now to begin our session, I call upon Fatima, member of IEEE SB to give the welcome speech.
Good evening, everyone. Myself, Fatima. The whole world is fighting against the coronavirus. In this time of vigilance, we need to make the most of even the limited circumstance before us. I consider it is a great privilege to be a part of such webinar on Pythons in today's industries, and I personally appreciate all the people in the meet. It is my duty to welcome everyone who is a part of it today. Our respected principal, Dr. Radhakrishnan R. Sir, who stand by all our activities with presence and cooperation, welcome, sir. The esteemed speaker, Mr. RIVAS HAMEED, enthusiast and Python evangelist, technology expert with more than a decade experience, worked with multiple MNCs like Infosys, Microsoft, Intel, McAfee, Dell, EMC, RSA, Tutori, the learning partner. Welcome, sir. Next, I welcome Branch Counselor Ms. Kartika Nair ma'am and Chapter Advisor Ms. Srilakshmi Nair ma'am, who stand by us for our needs. Welcome, ma'am. Next, I welcome all the heads of department. Welcome all. Next, I welcome all the executive members and all the members who work with us for the success of this program and those who have accepted our invitation and arrived. Warmly and respectfully welcome to this program. Before we get started, once again, I would like to express my hearty welcome to all of you. May God bless you all abundantly.
Thank you, Fatima.
Today's session will be conducted by Mr. Rivas Hamid, enthusiast and Python evangelist who speaks at various conferences and meetups. Technology expert with more than a decade experience. Worked with multiple MNCs like Infosys, Microsoft, Intel, McAfee, Dell, EMC, RSA. We are very much honored to welcome you, sir. Sir, please.
Yeah, good evening, everyone. Welcome, everyone. So we're going to talk about, let me first share my screen. Can someone just confirm if they can see my screen?
Yes, sir, it's visible.
Okay, all right. Okay, so thank you, and thank you for those kind words. And so I want to welcome everyone to this webinar. So the webinar is about applications of Python in the industry, right? But we're not just going to explore this world of Python in the industry. I want to give you a glimpse of how Python is being used by people outside the industry as well, right? Hobbyists. So what I want to do by the end of this webinar, hopefully I would impress upon you, how far-reaching this language is, and at least get some of you to, it's sort of evangelizing the language, and at least get some of you to start using it, right? So, but before that, let me ask a couple of questions just to get, a feel of how this audience is like. So how many of you have programmed in Python? How many of you have, you know about the language and you have kind of programmed in Python? So put it in the chat. Okay, so Sadashiv Bhaskar has used Python. Anyone else who has used Python? It might be even a hello world, but just like, I just want to know if anyone has. Okay, Alan Roy has done. Feba has done it. Cool. Okay. Great. So some of you have actually done this, and can I get someone to tell me, like, what their experience was, or where they used Python, in what capacity they used it? Anybody? I'm just trying to understand, like get a feel of the audience. That's all I'm doing. So let me ask, Alan. You have raised your hand. So where did you actually use Python? Did you use it just as a sample hello world, or was it more than that? Okay. Cool. I mean, I understand. Okay, that's fine. Maybe let's continue. Right? Like I just okay. So Sadashiv Bhaskar says is a professional from HR industry and has used in the capacity of data analysis. Perfect, perfect. That's a great instance of where you can use Python, right? Data analysis, and we'll cover a little bit of that, in the upcoming slides. Okay, now how many of you have heard of Python, but you've not really done any programming in it? You haven't done anything with it. Okay, Sona has done. I'm guessing there's a few more people who have actually heard about Python, but they haven't actually explored it, right? So Bibin Samuel, okay, a couple of people have done that. Okay, my last question is, how many of you have not heard of Python and you're hearing it for the first time now? Is there anybody in the audience who's not even heard it at all? Okay. So there's usually, like in my previous talks and all, I've at least had 1% or 2%, but it's always been the same trend, right? People have heard of Python. Python is ubiquitous. Like it's something most college graduates would have definitely heard of. It's and maybe they have done some bit of programming in it. Maybe they have not really done much of programming in it. But hopefully by the end of this talk, what I want to do is for people who have heard of Python, not really seen the programming syntax, or people who have not heard of Python at all, for them at least I can give you a gist about what Python is like. Okay. And for those people who have programmed in Python, I want to show you where all you can use it, right? You may have just used it in data science, for example, but let me show you the other world of it. Like, what are the other areas that you can use this? So a bit about myself. I think you have most of you have covered this a little bit. My name is RIVAS. I'm from Thrissur, right? I've been in this industry for now, I think it is 18 years, okay? And I have donned a lot of hats. I have had a lot of roles. So when I started off, I was a QA engineer. And as a QA engineer, I was supposed to, do manual testing. So they would give me this huge Excel sheet. It was pretty big. It had like some 100, 200 test cases, and we had to manually run that test case against the product. So our product was the Windows operating system, right? So our client was Microsoft, and we basically were doing QA on that. Then after some period, it was I evolved, like I started with automation, right? It was initially with command line, right, bash script. And then slowly I moved to something a little higher level, like C#, and I worked with C++. Then I found Python on the way, and I've been hooked on Python ever since. So for the past 8 or 9 years, I've been using Python in various capacities. And this probably, like all, whatever I'm going to go show you is basically an exploration of the areas that I have covered. I have also been part of the DevOps, streamlining these software releases. I have been a developer. There was a website, handling a couple of websites, maintaining that, and creating tools, things of that sort. So I have right now I am leading a team of engineers who are involved in the system and performance validation of a product, right? So that's just about my industry experience. But on the side, I love working with very passionate young people like you. So as you grow older, you sort of dip down in energy, right? But you have a lot of experience, but your energy is less. And as you meet up with energetic people like you, I am able to share my experience with all of you, and I'm able to get back, some of the energy that I lost. So I always love talking with young people like you, and I always love interacting with it. And as part of that, I'm right now affiliated with a organization called Tutory. I put the contact information over there. So Tutory is essentially an organization. It's a startup that aims to provide industry experience to young professionals like you, right? And it equips. So basically, when you're working inside an industry and when you're working outside the industry, there are big differences, right? In the mindset that you have, in the way that you code. So the Tutory sort of is trying to fill that gap in. Right. So I've just put the contact information over there. For anybody who's interested in knowing more, please do contact it. Okay. So why is Python so popular? Right. So that's we all know that Python is popular, right? I didn't get a response to anyone who didn't know Python, right? It is popular. Everyone has heard of it. And why is it popular, or is it even popular? So I have a chart here, and this chart is essentially, it's only up till 2018, but what it does is it sort of it marks the trend of the different languages that are there. So if you look at Python, it has come from 2012, it has steadily increased, right? There's a steady increase in the number of views on Stack Overflow. So that means there's a correlation between the number of views and the popularity of the language. So you see that steady increase as it keep going up and up and up, right? It doesn't tell you that Python is the most popular language. What it tells you is it is being widely adopted by a lot of people, right? And why is that? Right. So there's a couple of reasons. The first is it's a very intuitive language, and I have an example here. Oh, by the way, this is a quiz question. I just wanted to check with you. Now there is 1, 2, 3, 4, 5, 6 languages over here. Who knows which is the oldest language in this? Any guesses? Any guesses on which one of these languages is the oldest?
Java.
No, Java was developed in 1995. C is not there. C++ is the oldest one. It was done in 1980. Okay, that is the oldest. Okay, someone said PHP. PHP is also not the oldest. PHP came out in 1995 again. You know which is the next oldest? Any guesses? So the next, no. So again, no, it's not. So the next oldest is Python. So Python actually came in 1991, and JavaScript came in around, I think, was it JavaScript, Java, and probably PHP came around the same time, somewhere in 1995. Not very far from Python, but they came later. And C# came much later, right? It came out in 2001, I think. So Python is pretty old. It has been the old. C is the oldest. I don't have C over here. C is older than C++, but that came somewhere in 1970s, around that time-ish. But C++ is somewhere in 1980. Yeah. So it was C++, Python, then you have JavaScript, Java, and PHP around the same time, and C# is the youngest of these. Yeah. Just a quiz question. So that's how old Python is. So Python is not like a very relatively new language, but for a large period of its time, nobody knew about it. Okay, so let's talk about why Python, right? So Python, I said it's a very intuitive language. And let me, this is an example of, how you can print hello world in Java. Yeah. Anybody know what's the equivalent of this in Python? Oh, okay. No worries, Ajay. No issues. Yeah. Anybody knows? Okay. Anybody who can see this, who can tell me like what is the equivalent of this in Python? How do you print "Hello World" in Python? Great. Okay. So Ajay has actually given the answer, right? So you basically do it as print "Hello World," right? So if you do from Python and you run it, that's how we do it. Now compare that with what you saw in Java. You had something called as there was a class you had to define, and then you had to define a function. You had to define if what the whether it was private or public, right? And all of those things. So the one of the reasons that Python is really popular is because the language is very intuitive. It is very simple. It's written in a human readable format, and that was by design, right? So when Guido von Rossum, who developed the Python language, he had a philosophy with him. He said that coding is a social responsibility. That means you don't write code for yourself. You write code so that others can also look at that code. And it has to be readable, right? It has, it's the number one criteria is that it has to be readable, and then only can you maintain it. So he has put a lot of emphasis on that. You can actually, if you look at the way that the code is written, it's very it's print. It's not console.write line or something. It is print. If you want to read, it is input, right? So remember, in the industry, you do not own any piece of code. Right? You write a piece of code, but it doesn't belong to you. It's not your baby. You basically, once you write a line of code, that line of code is inherited. The next set of developers inherit it, and they have to modify it based on their needs. So it's always in that fashion, right? So as much as possible, he has tried to remove unnecessary pieces of code, and it's the syntax is simplified to a very large extent. Okay. Here's another example. I know some of you can't actually see the. Can all of you see my screen, or is it?
Yes, sir. It's yes, sir.
Okay. Can you tell me like what is the output of this? I don't want to make this like an interview, but it's just to prove a point. Can someone tell me what could be the output of this particular thing? So it's nothing. It just does I equal to 10. It does a comparison. If I is less than 10, it basically prints out either result 1 or result. Okay, so the second line is result 2, right? So this is result 2, and this is result 3. So so which one does it print out? Result 1, result 2, or result 3? Any guesses? You guys can actually say the wrong thing. I intentionally made it difficult to read. Result 2? Okay, someone said it was an error. Result 1? Okay. Great. Now I'll show you the equivalent of this in Python. Okay. So this is how you would write it in Python. So nobody is going to write code in this fashion in Java. Okay. So I'm just proving a point here, right? But if you look at it in Python, is it more readable? Can you get the result out of this faster? Right? Actually, the answer is you don't get any result. Nothing gets executed. Right here, if you look at the code, if I is less than 10, I'm sorry, result 3 is the answer. So if I is less than 10, then it goes into this. But none of these lines actually make any sense because this is checking for greater than 100 and greater than 50. So because I is equal to 10, it will come here, it will print result 3. Now, the point that I'm trying to make is, in your Java code, you can write it in such a fashion. The language allows you to write it like that, right? But Python forces you to indent your code. So that means if you write it in any other fashion, it will throw an error. And it is much more readable when you put it in this fashion, isn't it? So that's just an example of the emphasis on that readability part. Okay. So yeah, the point here is it's very difficult to follow the code when it is structured out in this fashion. Another reason why Python is used a lot is because it's got a large number of third-party libraries. So I had created this this presentation sometime back. So at that point of time, it was 2 lakhs. 2 lakh projects are there on the PyPy. PyPy is like your repository where you keep all your libraries. So you can install. You can like for example for data science, if you want to install some package that will help you with your task, you can install it from this PyPy. And so if you just go to pypy.org, you'll see this. And you'll also see like how many projects are there. So I just checked it today. It is around 3 lakhs 14. So it increases. It's continuously increasing. And there's just a lot of stuff over there. And the reason why there's a lot of stuff over here is because people are adopting this language and a lot of communities are being formed, and each of their each community will have their own agenda, right? So there are some people who are studying pollination, so they're basically building tools to examine that, right? All the statistical stuff. There's a lot of traffic analysis community who does that. They've created libraries over there, and you'll slowly see that these projects are continuously increasing, right? So there's a huge third-party support that you will get. Almost anything that you need, it will be there. Some library will already be there. Okay. Now, okay. So this is the number of. Here's a chart, and this chart kind of tells you like how many users are there. Again, this is a little old. This was done in 2018. Now I guess it's a little bit. I mean, the numbers would be different, but you can clearly make out, right? Python is popular than more popular than Java, C#, C++, and all that. JavaScript is not yet a competition because JavaScript is used in your web browsers. There's no other language which actually you can run in natively on your web browsers other than JavaScript. So JavaScript, and also plus with the Node.js ecosystem, I think JavaScript is just exploded. So JavaScript is by leading by a huge margin, but second is Python, right? So you can see that Python is growing in popularity. There's a lot of developers over there, and they are doing crazy stuff with Python, right? Now let's the third reason why Python is popular. So I said. The first reason was on the readability part of it. It's easy to learn. The second part is there's a lot of developer support, right? And the third part is it's general purpose language, which means that it can be used for a lot of applications. And now I'm going to kind of show you the different ways that you can use Python. So before that, any questions? Anybody has any questions on anything that I've covered so far? Okay. Okay, so the first part is data science. Okay, so the first field that I'm going to talk about is data science, right? So someone already mentioned that they had used Python for data science. So this is one of the reasons why Python became popular, because a lot of data scientists started adopting Python. They started creating a lot of libraries around it, and because of that, that Python, the world of Python just exploded out over there, right? So what is data science? Data science is a way by which you can extract some meaningful results out from large amounts of raw data. Now that data can be from multiple sources, right? It can be something that you scrape from websites, or it can be some CSV files, it can be some Excel sheets. So it can be from anywhere, right? But once it comes in, you basically have to filter through the data. You have to remove all the unnecessary data, and you have to the redundant data and duplicate data, all of that you got to clear out. And then you have to analyze the data using some algorithms, right? And then you create a data model. And that data model is then used to predict something or classify something, right? This is another aspect of data science, is taking that prediction or classification and plotting it in a visual way. And this visualization is then used to guide leaders to make better decisions. So that is why data science is really important. right? We just have a lot of data coming in. So why is Python being used as part of data science? Now, you have other languages. You have languages like R. R is basically a language which is focused on statistical computations. So a lot of statistical scientists use R. But the reason why people flock to Python for data science is because one, it is easy to learn, which means that when people who are coming into data science, like new people who are coming into data science, they don't want to spend time on learning a new language and understanding its semantics and its complexities. What they want to do is they want to start focusing on the data science part of it. And Python is easy to learn. R isn't as simple as Python, right? So that's one of the reasons why people take up Python, because they say that, oh, you just have to run these commands and you get the results out. The second reason, not the second reason, but there's another group of people who are actually developed applications and everything in Java or C, C++, right? They visualize problems in an object-oriented way. R is not object-oriented. Python is an object-oriented language. So they natively tune themselves to Python because they can build their solution in an object-oriented fashion. And so the whole solution, when they build it in an object-oriented fashion, for them it is more maintainable. It's more, they can make it more readable, right? So maintainability is a very important thing in industry. You sometimes there are I know a friend of mine who is working in COBOL on a mainframe computer, right? So COBOL, that the only reason that it is existing today is because it was maintained. So it was built in somewhere in 1990s or 1980s. So it is as old as that, but it has come down from that, and they've just maintained that process because it's difficult to do it any other ways. They have invested a massive amount of money for it. Now it works. So why move it out is their logic, right? So maintainability is very important in the industry world. And the second reason is, there are a lot of libraries, right, in machine learning. So let's let me just reiterate what are the steps in data science. So we talked about data acquisition, which is basically acquiring all the data and preparing the data. And then you have to kind of analyze and create models from the data. And then the final part is visualization. And Python has different tools which will take care of these things. So for each step, there are certain tools that you use. So I'm not going into too many details, but I'm just listing out some very common libraries that you use. These are not the only ones. There are a lot of other tools that I use: NumPy, Pandas, Matplotlib, Scikit. So most of you might, people who have used data science would be familiar with these libraries because they used a lot of that. So the second thing is the web development. Okay, so web development. So here, if you look at it, there are a few things that I have actually marked out, right? So these are all basically web frameworks: CherryPy, Bottle, Pylons, Pyramid. So they're all web frameworks which are built in Python. But the one which is very much in use is Django, Flask, Tornado to a lesser extent, but Django and Flask are the most popular out of all the web frameworks. So most people are, Django, yeah. Okay, so Django and Flask are the most commonly used Python framework for web development. And what is let's look at the Django. Okay, so now anybody has an idea of which is the largest deployment of Django? Which product uses Django the most extensively? I mean, the biggest deployment of Django is what I'm looking at. Okay, yeah, Instagram, right? Instagram actually uses Django in its application. So basically, it's not. So what happens is there are REST APIs, and all these mobile phones and all and your website and everything. They query the Django servers to get their data, and Any idea where these YouTube? Yeah, YouTube started off with Django, but they have actually moved on, I'm guessing. So any idea? So the Instagram basically started deploying their Django servers on AWS, right? So how it works is in Django they have these application servers, and they have picked up like the most. So in Amazon you basically can select what compute instance you want, like what kind of server you want. The EC2 instances is what it's called. So you can have T2.micro, T3.micro. You have T2.large, right? So Django actually, I'm sorry, Instagram actually uses the largest compute instance that is there. And initially they had some, they had lesser number of users, but today they have around 1 billion users who are using the Instagram website. So 1 billion is a lot of traffic, and Django is basically able to scale, right? So that's a testament. That's a testament for Instagram. I mean, for Django, sorry. What are the other companies that are using? So YouTube, yes. Spotify as well uses Django. Pinterest is another website that uses it. Mozilla, National Geography, OpenStack, Discuss. So Discuss is, all of these are like, I think Pinterest and Discuss are social media, social networking sites. Mozilla is your browser, and National Geography is your that TV channel. OpenStack is something which is something like your VMware, right? So they all use Django in their backend. Great. So let's go to the next one. Automation. So this is something that is very dear to my heart, right? So because it's been something that I have contributed a lot to. So when companies become large, when large enterprise or even medium scale enterprises, they have to make sure that every functionality of your product works, right? So I told you when my first company was Infosys, right? And when I joined Infosys, they had given me this Excel sheet, and it had some 100 test cases or something, and sorry. So I was supposed to run those 100 test cases manually every time a release was there. Now imagine, and Microsoft, the way it does is, you have like one mainline release, which is like your, say, Windows 7, Windows 8, Windows 8.1 is another mainline release, Windows 10, and if Windows 11 is coming, that's a mainline release. And then you have the concept of service packs, which is like a lot of fixes are bundled together and deployed. And then you have a concept called as hot fixes. So let's say there is a customer who wants one fix and he needs it immediately. He cannot wait for any updates or anything. Then a hot fix is generated. Okay, so there are these different kinds of releases. Every time something comes up, right? Every time some kind of release is there, I was supposed to run those 100 test cases manually, right? Now, most of the test cases, so out of the 100, 90% of them would pass, right? That was the way it was. Like, it doesn't break everything. So the first day I did it, it passed. Second day I did it, it passed. Fifth time I did it, it passed. 10th time it passed. 11th time, what would you expect? I would expect it to be passing, right? Now that's a problem with humans. Humans, so the 11th time, I'll just expect it to pass and I won't look for any failures. But a QA, what is a job of a QA? A job of a QA is to break systems. He's supposed to look for any failures. He's supposed to dig through the product, understand its functionality, and see how you can break it. Right? That is his job. If the QA's job was to go through a set of ritual tasks and just run it and then make sure that everything is working fine, then at some point he will be doing a bad job, right? Now, automation is not like that. Automation doesn't care how much time it is doing. It will do that repetitive task, correct? And whether it be 100th time or 200th time or 1,000th time, he will do it with the same focus as the first time, right? So the automation is important in every industry, because if you have to find any regressions means any change, erroneous change in functionality, you cannot depend upon humans. You have to use some kind of automation, right? So that is why that is important. Now, in the company that I'm working, I have around 8 to 9 teams. Okay, so there are 8 to 9 teams working together on a single product. And each team is focusing on one particular portion of the product because these products are going to be very huge. So they'll be focusing on one portion of the product. Now, another instance of where automation helps is now, usually like people will test only when there is a change in their component, right? So they are focusing on a single component. They will say, okay, we haven't made any changes, so nothing will break. That's a normal psyche that they have, right? Normal thinking that they have. So what happens when one component makes a change, and because of that change, there is an error that will happen in another component. Right. So in our company, what we do is we run these automations. We have multiple releases. So we have like 10, 12 releases that are there at the same time. So we basically run automation against all those releases, I think like every single day. And if there is a failure because of like this overlapping failure, right? Like in the integration tests, then we will find it within 24 hours. And we should basically, once you find an issue, you're basically supposed to assign that to that team who owns that component, and they're supposed to fix it. So that is how important automation is. And there are different types of automation, but at the base of all automation is something called as a test automation framework. What is a test automation framework? So so test automation framework is nothing but it's a platform, right? It's a platform where both QA and dev writes their test. And there are some hallmarks of this platform, right? The first part of that is that, the coding standards. What is coding standard? So let me give you one metaphorical example, okay? So different parts of Kerala, there are different dialects, right? Different slangs. So, you have a lot of jokes where one person from, one area speaks in some fashion and it is misinterpreted by another group of, in another district, right? Now, a test framework also, right, in the same way, if your code is having different ways of writing things, then there are chances that it may conflict with each other. So a test framework is important to set a coding standard. That is one guideline. That's a guideline for writing code, right? So there is no room for misinterpretation. That is one important thing that a test framework does. The other two, like test data, handling your test data and external resources. What is test data? So basically how a test works is you give it some input and you get some output. If the output is not the expected one, then it's a failure. Your test is failed. So your test data, let's say there is some change in your test data. So external resources are basically, let's say your test has to access some live server, something, I don't know, google.com. Tomorrow there, some change happened. Now you cannot use google.com. You have to use some other website, right? I'm just giving an example. Do you have to go into every test and make that change? Like if the test data changes or that live server changes, do you have to go into every test and make that change? Ideally, you should not, right? Because if you do that, then there is scope for failures. So the way a test framework should handle that is there should be only one place that it is defined, and every other test basically consumed from that one place. So you just make what change in one place and it gets pushed to every test. That is the way it is. So that is the handling test data and handling external resource. Displaying output is also something which a test framework takes care of. What is displaying output? So basically, once you run this test, you get X failures, Y number of passes. So you have to put it into a report that has to be pushed. So if I'll be talking about something called as CI/CD later on, but basically there are these servers which will read these things and generate a dashboard where you can see all the failures and all the passes, right? And if there is a failure, you have to be able to go in and see the debug where the issue happened. So you have to have logs. So all of this is something which is common across all tests. And that is something which falls within the purview of a test automation framework. So a test automation framework is pretty important, when you're writing tests for large organizations. When you're writing it for yourself, it doesn't really matter. When you're writing it for very large organizations or medium scale organizations as well, it's a pretty important thing. So there are, I'm just to give you the flavor of how it looks like in an industry. There are different types of testing framework. The modular test framework, the keyword-driven test framework, behavior-driven test framework. And I'll just give you like a very brief description of what those are. Okay? So modular test framework is nothing but, I talked about different teams working together, right? On different teams are focusing on their own components, but finally they're working on one product. Now, each team will write the test framework has to be built in such a fashion that every team can have their own set of dependencies. Like for example, so the login page will not be linked with. The login page has its own set of functionalities, and the login may be related with your login, logout, and all that. So maybe that authentication piece is one, but then you have also the other part, which is your computation, right? So how it processes the data, right? So that is another piece, and that those both are not related. So they'll be two different modules. Maybe that computation is also split up into different places. Maybe the front end is another place, right? So different teams will have their own set of responsibilities, and they have to be separated out into different modules. So your test framework should allow that by having a folder structure or having some way by which each component owner can place his code and things. And he should also be able to call the test data, right? He should also be able to take the test data from one place. He should not be putting it along with his code, right? So all of those coding standards and guidelines should be there, but it should support different teams to work together without causing confusion amongst themselves. So that is a modular test framework. And there is examples of like some frameworks which you can use for doing that. So PyTest is one, PyUnit is one, XUnit is a generic term. But yeah, so PyTest and PyUnit are the more popular ones. Then the next one is keyword-driven test framework. Okay, so keyword-driven test framework, it is actually, so what a keyword-driven test framework does is, so imagine a test. Here the example is a reset login application and the login application, right? This is just this is maybe not the perfect example, but what it does is they have some common steps. Okay. Now imagine you're working in a modular environment. Your test framework is modular. Each team is working on their own set of tests, but some functionality is common, right? So some functionality here, if you look at it, go to a URL, right? Now, if you don't define this functions, if the test framework doesn't define that function, then what happens is everybody will implement their own version of GoToURL, right? It might not even be called GoToURL, it might be called something else. So one team will build GoToURL, one team will call it as navigate to website, one team will call it something else, and they will be same code under different names, and that causes something called as code bloat. Your code will get bloated. So to minimize that, the concept of keyword-driven test framework is you have all these common applications, all of your actions to be defined, and it's something that each of the modular tests will invoke, right? So this is more related with, when you are, we talked about test data, we talked about external dependencies. That could be something like a database or a live server or things of that sort. So all of those things should be having a keyword, and you use the keyword basically to do it. Now there are frameworks which uses that, like Robotium, for example, uses that to a very good extent, right? It does it very well. So you basically define your keywords, and you can have, like, you can define your arguments as well that you pass to that keywords, and it makes it very readable, right? So those are the hallmarks of a keyword-driven test framework. right? And the behavior-driven test framework is this is really cool, and this is one level above keyword-driven as well. So you have modular, you have keyword-driven. Behavior-driven is a way by which you can use your test cases as a manual. So let's say you have a website, and when you log into that website, given a valid username and password, then you have to be able to log in. So you base your behavior, you're defining a behavior for that website. You will write all your test cases like that. You will so even before you write the code for it, you would have already written down these test cases. You would have said, okay, I have to make sure that my website is everybody can log into my website if they have the right credentials. If they don't have the right credentials, they should not be able to log in. So you write your test cases in that fashion, right? And then basically only after that you start coding. So there are this behave is I've used it, and the first time I used it I was floored by the way that it handles it. So behavior driven test framework, it is exactly what I told you. You basically just write out your code in human readable language, right? When I do this, given this, when I do this, then this should happen. And then you start coding for those separate, like the given part, the then part, when part, right? And then you can basically use that given in other test cases as well. So it's a really, it's not very new, but it is, it's slowly coming into fashion now. So most people are using this. So that is about automation. Okay, the next bit is about DevOps. So in DevOps, you have two concepts, CI/CD. Anybody knows what CI and CD stands for? CI stands for continuous integration, and CD stands for continuous deployment. Okay. So what is continuous integration? So continuous integration is, when you are making a startup or when you're working in a company, your primary goal is you want to give a great product to your customers, right? You want to build a great product. Now, the way that you build is you don't build. So traditionally, what we used to do is we used to have a waterfall model where we used to build an entire software. We give it off to the QA to test. They test it. If they find any issues, they return it back to the dev people, and they used to fix those bugs. So they'll basically just raise bugs, defects, and the dev guys will actually look at those tickets, fix the issues, and then finally it is released. Now the problem with that is what we found is every time you did something like that, we used to get the release used to get delayed by 6 months, 7 months. It used to go even beyond that. So your project itself may have taken 6 months to develop, right? So your product itself was 6 months, and then you took another, because of the defects that were raised, you took another 6 months. So total of 1 year was spent on getting that project out, right? So this was not ideal because there is a lot of impact because of this. So normally when I develop a product, I will have given a promise to my customer saying, hey, I'm going to give you this product 6 months from now. And if I'm not able to deliver within, if I'm not able to deliver by 1 day also, there's a big problem. Here we're talking about months. So we needed another model, and slowly we have come to this agile model. And the whole principle of agile is that you build your software in increments. You don't build the entire product in 1 day or like together. You build a small piece, and then you once you push that code into the your versioning system like Git or something, all the tests get run. All the acceptance tests, all the non-performance tests, the component level tests, system level test, everything gets run, and it gives you a list of passes and failures, right? And so that whole process is continuous integration. From the moment that a developer commits his code into Git, from that, we have to generate an executable, something like an exe in Windows or something like a DMG in Mac, or something like Linux. In Linux, it would be some RPM or TED file, right? For Python, we don't really normally create that, but we can. A lot of people are actually creating Docker files, right? So basically, it has to create a Docker image. So all of that is the orchestration part of it, right? It basically has to build an image. It's a build part of it. And that once it creates a build, it has to run all the automation. Once it runs the automation, it has to create a report which will say that this is passing and this is good to release to, this is good to release. There are no issues in this. So that entire thing is called as continuous integration. And we use different tools like have you heard of a tool called as Jenkins server? So Jenkins server is typically used a lot. Like it's kind of free, so most people use Jenkins server. So Jenkins server, you are able to put it into jobs. You will say that, okay, a git commit happened, so trigger this job. Then this job will trigger the next job. Then this job will trigger the next job, trigger the next job. And finally, it pushes it into some internal repo saying that, okay, new build has come. Right? So that entire process is continuous integration. So here's a diagram of how it looks like. So from Git, you basically gets pushed, and this is something called as Travis CI, something like Jenkins server. And Jenkins server then this triggers this Travis CI. It runs a code analysis, it runs all the test coverage, and it's ready to release. So that is called as a continuous integration. A continuous deployment is basically deployment of that code to the production server if all checks pass. So that means you're so confident about your continuous integration that you can actually push it into production. So a lot of companies do it now. Netflix, for example, I believe the number of days is it has around 4,000 deployments per day. That means 4,000 times it pushes some update onto your Netflix website. So if you use Netflix for viewing all these videos, you won't even know that it is happening. It's happening in your background. AWS does deployment to their servers. I'm talking about that Amazon web server every 11.7 seconds, right? And it's seamless. You don't even know that something like that happened, right? So that's how the whole process should be. But most companies aren't up to it. They are still, it's very difficult to get to that stage. It requires a lot of diligence, a lot of focus. So most companies aren't there by any standards. So where is Python coming in all of this, right? So in Python, what you need is, Python is a strong scripting language, right? And for this, again, I told you, Python is very readable and all that stuff. It's also a strong scripting language with access to a lot of libraries. So there are other languages. Python is not the only one. You have Ruby, you have Go. All of these are other languages which are being used. But still, because of the use and usability of it, you find a lot of DevOps engineers coming to Python. So these are like some helper libraries. And this shows, for example, Git API. Git API is something that you use to connect with Git, right? Now you may have GitHub, you may have GitLab, you may have other Bitbucket, you may have Mercury. So you have different integration plugins already in Python which can talk with all those. So that is where all that libraries come into stuff. What is Boto? Boto is something which talks with AWS. Google Cloud Storage is one library which is used to talk with the GCP, the Google Cloud Platform. Ansible is something, so there are something called as orchestration tools. Orchestration tools are basically something that will, so suppose you have to test out, you build an RPM or you build one product or ISO or whatever, like, the final one bundle your application is going to be deployed in. So basically that has to get pushed, that has to get tested, like it has to be installed somewhere, right? So Ansible is something which will actually set up your servers. It will install your operating system. It will install your environment and everything, right? So Ansible and Salt, what's that, Chef. Chef Salt is also another one that is there. Salt Stack. Then you have support of any database. Most databases are supported, right? I mean, you could say all databases are supported in Python. So MongoDB, MySQL, PostgreSQL, you have plugins which will talk with those. Then you have tools like Fabric, FabTools, Cuisine, which are basically used to do automated, repetitious administrative tasks. Like let's say, so with Fabric, even if you have say 100 machines and you have to apply a patch on all the 100 machines, Fabric is a tool where you can just, it will automatically go to each box, SSH into that box, apply the patch, get a result, and come back. So FabTools and Cuisine is similar kind of tools. So you have.
Excuse me, sir.
Yeah.
It's 7 p.m. It's time to end the session.
Oh, okay. Fine. Give me 5 minutes.
Make it faster?
Yeah.
Okay, sir.
Okay. So this is basically about the DevOps. Now, you can also use Python for creating desktop software. So I'll just go through the major things that are there. tkinter is something which comes inbuilt with Python. You have tools like PyQt5 and Kiwi, right? Both of these are very much in use. And they are essentially cross-platform, which means that if you build something with PyQt5 or Kiwi, you can actually run it on any platform, even your mobile phones, right? And the gaming is the, it's not restricted. I mean, this is not an exhaustive list, but gaming is another area. So typically Python is not used for gaming, but recently, it's a very recent trend. There has been a very increased popularity of a framework called as Pygame. And these are just examples of the games that are being built on that, right? So even today, Python is not recommended for building games, but you can see like how crazy they have done it. They have also a version of Mario. This is a Street Fighter, which is an old game. They've made it in using Pygame, right? And these are like a variation of Sega games that are there. So here's so just to recap, I talked about about why Python is popular, right? And the main reasons for it is because it's very readable, it's very simple to learn, right? The learning curve is much simpler than other languages. You have a large number of communities over there who have, so you have access to a lot of libraries. And the general purpose nature means you can use it for almost anything, right? It might not be suited for that area, but you can still go ahead and use it. So with one language, you now can do multiple tasks. And we kind of covered a lot of areas where it is being used. Yeah. And that's pretty much it, right? So I'm open to any questions if there are any.
Thank you so much, sir. It was really an informative session. Thank you.
Okay. All right.
Thank you, sir. Now it's the time for doubt clearing section. So everyone may ask their doubts or type in the chat box.
All right. Right. I think looks like no one has any doubts.
Okay, now I welcome Assistant Professor Ms. Kartika Nair, Counselor of IEEE SNIT, to hand over the certification of appreciation to our speaker, Mr. RIVAS HAMEED, sir. We are very much honored to welcome you, ma'am. Ma'am, please.
Thank you. A very good evening to one and all present here. First of all, let me introduce myself. I am Kartika Nair, belongs to IEEE department, working as an assistant professor and also being a part of IEEE as the branch counselor. Firstly, let me congratulate all my dear students, those who participating in this event. Then I would like to thank you our speaker, Mr. RIVAS HAMEED, for enlightening us with his knowledge. On behalf of our IEEE student branch at SNIT, now we are giving a small token of appreciation to our beloved speaker. It's a tangible way of showing our gratitude. Thank you so much, sir.
Thank you. Thank you a lot. Yeah.
Thank you so much, ma'am. And once again, thank you to our honorable speaker, Mr. Rivas HAMEED sir, for your time. Your presence have been very valuable to us today, and we certainly look forward to another interaction in the near future. Thank you so much.
All right. Thank you.
Okay, it's time for feedback session. If anyone has any feedback about the session, you are welcomed.
Hello, sir. Thank you for the wonderful session. This is very helpful and informative session. Thank you for the wonderful session, sir.
Thank you, sir. It's me, Bibin Samuel. I have heard about Python many of time, but I never know deeply about it. Thank you for the wonderful session. I get to know more about it. Thank you so much, sir. I am looking forward to learn more about Python in future. I am a third-year student. I am looking forward to it. So thank you for the wonderful session. It was very informative for me. Thank you.
Okay. So if anybody has any doubts, or if anybody wants to get in touch with me, please, the number that I shared, or you can actually contact me through that email ID that I shared. I'm more than happy. So I think a couple of you have actually, interacted with me on LinkedIn, like they've sent a friend request to me. So I'm more than, open to, having conversations with you. So, sure. Let me give you the email ID once more. It is contact at 1 minute, and there you go.
Okay, now I invite Avarna Mol, Vice Chair of IEEE SB SNIT and IEEE IAS SBC SNIT for the vote of thanks.
Good evening to one and all. As all good things comes to an end in life, so is this session. It's really great that this program has turned out to be very successful. I, Avarna Mol, Vice Chair of IEEE SB SNIT and IEEE IAS SBC SNIT, and it's a matter of pride for me that I am proposing the vote of thanks for this session. On the behalf of my colleagues and the entire student chapter members, first of all, I thank to God. I want to thank our chief guest, Mr. Rivas HAMEED, enthusiast and Python evangelist, technology expert with more than a decade experience, worked with multiple MNCs like Infosys, Microsoft, Intel, McAfee, Dell EMC, RSA, Tutory, the learning partner. Thank you, sir, for an informative and profitable session. Next, I would like to thank our principal, Dr. Radhakrishnan R, for his great support for the conduction of this program. Thank you, sir. Next, I want to thank our branch counselor, Ms. Karthika Nair ma'am, and chapter advisor, Ms. Lakshmi Nair ma'am, for presiding over the event and motivating and inspiring us at every step. Thank you, ma'am. A special thanks to the organizing committee and teachers for the influencing support and coordination. And last not the least, my heartfelt thanks to all who have actively participated in this session. Hope you all have enjoyed it. Be safe and wear masks and take protective measures against COVID-19 pandemic situation. Stay safe. Thank you.
Thank you, Avarna. Now I request all the participants to turn on their video to take a screenshot.
So it's a time to conclude our session. Now all the participants can fill the feedback form provided in the chat box.
Thank you, sir.
Okay, all right. Then I wish you all a good evening and wish you all the best for your future.
Yes, sir.
Okay, let
It
us
was nice
conclude today's
session.
session by thanking everyone who participated in this session and making it a great success. Now we are winding up our session. I wish you all a nice day.
Bye. Bye all.